up to you to choose what you want.
I have a question. The cookie authentication, what is the encryption form of it, or it's just a string 64?
What is the encryption stuff of the cookie? We will come on to that.
Okay.
We'll come on to that when I talk about data protection, because that's what it uses.
Okay.
What is .p, by the way?
Yeah.
Time-based one token protocol something.
So it's an authenticator.
Yes,
Okay.
it's the authenticator app. It is the RFC for authenticator apps.
Okay.
So I got people like me to do demos.
Time-based one-time password.
There we go. Time-based one-time password. So it was originally Google Authenticator, and then, well, actually it wasn't. Originally it was an RFC, but Google were the first people to implement it. So it became known as Google Authenticator, but it is supported by multiple standards. So we have our awful templates that just never seem to be that exciting, but never mind. So I can log in. If I go up here, I can now enable two-factor authentication, and I get, out of the box, you'll see everything but the QR code, and then there are instructions to put in whatever QR code generating library that you want in there. Highly recommend doing this client side, because trying to draw images server side is generally a bad idea, because you end up with memory leaks, which is why we told no one to use system.drawing in their server applications, and then you all did it and made us very unhappy. So that is now in the box, which should make a bunch of people happy, because everyone sort of demanded it for a long time. So the way that we are configuring things now is different because of the way we rejig stuff. If you are porting an app from 1 to 2, this is what your cookie authentication options would look like in 1. And here it is differently in 2. So we are adding authentication to our services. We are setting our defaults to that authentication middleware, and then we are adding cookie into the authentication middleware. So that finally enables us to say that you can only have one active middleware at a time. So the defaults are a little bit weird, because we split them out into a bunch of things. Default scheme is the easy one. If you're only ever going to use cookie, just use that one and set it to cookie. Then we have default authenticate, which is used every single time a request comes through the pipeline. So in cookie's case, we're going to go look for a cookie, validate the cookie, and then rehydrate the identity. Default sign-in is where we go to when someone does a sign-in, and challenge is where we go to when you hit authorize. So if you were wanting to do social-based login, and you want to choose, say, I'm only going to allow people to log in with Facebook because I want to sell my soul to Cambridge Analytics, you would set everything except default sign-in to be cookie, because you need some way to persist the identity that Facebook gives you. And then you set default sign-in to be Facebook. And when the Facebook sign-in has completed, default authenticate, default challenge, that will fall through to the cookie auth, and it will save out a cookie with the Facebook identity, and then in every single request it will look for the cookie again. So our example is Twitter, because I just much prefer Twitter to Facebook for some bizarre reason. And that's how we've set it up. So we have default authenticate is going to be cookie, default sign-in is going to be cookie, and challenge is going to be Twitter, because that's where we want to bounce to log in. And again, if you want to do things manually, and we fully support this, in Katana we really didn't document very well how to use cookie authentication without all our identity pieces. People tried to reconstruct it and delete things and figure it out, but this time I stuck my foot down and said we need to actually document this, because we don't want people trying to write their own encryption mechanisms for cookies. It's just generally a bad idea. So you can do things manually now. You can call context.authenticate or context.authentication.authenticate in 1, or just context.authenticate in 2. And like I say, you can do it yourself. You can use the cookie authentication without anything else that we provide you with. If you don't like ASP.NET Identity, and I truly understand if you don't, because some of the table structures it generates is really bizarre, you can use the cookie authentication middleware. There's an entire docs page on this. So it will encrypt and sign the cookies identifying the current user principal. It will use data protection, which means we are generating a key ring that you need to synchronize between multiple servers. But it will roll that key, it will place time limits on things, and it will generally be as secure as we can make it. And then if you want to sign in and sign out, lo and behold, that's very, very exciting. But if you are doing it yourself, there is a problem. The cookie is the sole source of truth once it is there. We believe the cookie. If you are, for example, running a bulletin board and you want to ban a user in your database, well, you can set the flag on the database, but as long as their identity is in a cookie, we're going to believe the cookie. We don't go off to the database again to check it. You have to wire that up yourself. So you wire up a validator. And we use this validator within ASP.NET Identity to support things like sign out everywhere. And we check it about every 15 or 20 minutes. And you can use it to update claims from your backend changes. And they run with every single request. It's up to you to do throttling, because I'm pretty sure you don't want to go talk to your database on every single request, because that's going to be a scalability nightmare. So these things are reasonably easy. You just implement a static function with that signature. You run off to do whatever you want to do inside your database, and if you want to refresh, you call context.replacePrincipal with the new one, and call should renew as true. If you want to reject it, you call reject principal, and then you call sign out on whatever your cookie scheme name is going to be. And then you wire it up in the events for cookie authentication events, of which there are many, but the one that you want is on validate principal. Point it to your static function, and away you go. So we can sort of see this in action. Where's my validator? Oh, there we go. So here, I'm adding authentication. I'm going to tell it to use cookie for everything. And then I'm going to add my instance of cookie and set everything up. And lo and behold, there's my onValidate principal. The other thing to remember is in 2, you also need to use authentication into your app configuration. And here's a cookie validator. And then after every 5 refreshes, and this is not thread safe code by any means, every 5 refreshes, we will log someone out. So what we're going to do is run this, and it's going to keep a count of how many times I have, in theory, logged in. What I've done is in the code, I just hard-coded a login. So it's going to create an identity. It's going to persist it using the cookie auth, and lo and behold, I don't actually have to do any logging in. So if I keep hitting refresh on this, 3, 4, 5. Oh, look at that. After it's seen it 5 times, it will log the person out. And because I'm keeping a running count in the static and I'm logging back in again, I'm now on my second instance of seeing this. So this illustrates both validators and logging in and logging out. Here's my account controller. I am going to construct a claims identity, and then a claims principal, and then I just call sign in async with an authentication scheme and the principal. Now all schemes is a string-based name for a piece of authentication. Well, it's not middleware anymore, but the services that you add to the authentication middleware. And I'm just configuring it so the cookie will go away after 20 minutes, because I always forget. It's not going to be persistent. It's not going to allow refreshes, and I'm just going to increment things every time I see it. So does that make sense from using cookie authentication on its own? Yes.
Just want to recall my question related to the encryption of the cookie.
I will get there.
Yeah,
I
okay.
promise you I will get there. It'll be in the data protection bits.
Okay.
Anyone else?
So forgetting to kind of have speaker's block here, but cookies strike me as relatively insecure relative to, for example, JOT tokens. If you have client code, if you have code to in running in the UI that only chooses specific APIs. I mean, if you're not storing it in a cookie because of the fact that other sites can issue requests and therefore invoke URLs using your cookie.
So,
right.
Cookies versus bearer tokens. It doesn't particularly have to be JOT, but JOT is the most common one. And yes, in theory, bearer tokens are more secure because they do not automatically flow with every single request.
Right.
You have to manually add them.
Right.
However, the only easy way to do that with every single request is a lot of JavaScript. And so that's generally why it's used for APIs and AJAX calls. Because cookies flow with every single request, you are correct in that if you have not secured your site correctly, other sites can make requests to your site, and then the cookie flows with the request to your site, and that's called cross-site request forgery.
Right.
And there are ways to protect against that using cross-site request forgery tokens. And in .NET Core, we add those for you automatically. So you don't have to think about it. Well, you don't have to think about generating them. You have to think about validating them, unfortunately, and there's a validate anti-forgery token attribute that you can put on all your posts, because you would never ever change state in a GET request, right? So you would put validate anti-forgery token. Now, you can turn the validation of anti-forgery tokens on automatically, but we got so many complaints about that when we did it in betas, because they're like, okay, but it's just broken our web API, because I don't send an anti-forgery token to my web API. And I'm like, okay, but you have this exclude attribute that you can put on your API calls instead of putting validate on your HTML calls. But that was a bit too much for people to reverse. So you can set everything to generate and validate automatically, and then you just have to exclude that validation from your API calls as long as you are not using cookies for your API calls.
Great. Thanks.
And if you are using bearer tokens for your API calls, you can plug both into the pipeline. Now, people got really upset about this. People said, I want to just limit the token or the authentication type that I'm going to use based on path. If you're one of those people that logged that request on GitHub, I hate you, because doing things based on path in an MVC app where there are multiple ways to get to a controller, so path makes no sense, is not, in my opinion, the right way to do it. But because people asked so much, I give in, and eventually you'll get that in 2.1. The way that you can do it now, and the way that I still feel is the correct way to do it, is in the authorize attribute, you can choose the scheme that you wish to use for a controller or for a method. So I can say, I'm in my API controller, so I only want to use bearer, or I only want to use JOT, and the cookie stuff will be ignored. So therefore, even if you have logged in with a cookie, and you have an AJAX call that you want to make to the same application, which I'm not sure is a good idea from a security standpoint, but it's your funeral. Personally, I'd separate the APIs out and put them on another host. I mean, if you look at the way Google does Gmail, for example, the API calls that they make to Gmail are not the exposed API calls that your applications can make to Gmail. They are internal only APIs, but some people want to share the API that they give to third-party apps with their first-party app. And this is a way of saying, well, I'm only ever going to accept JOT even though I'm hosted on the same domain as my HTML application, and it's going to send me cookies anyway. So do it this way. Don't do it based on path. So, individual user accounts we have. It's your database, it's your models. We have Azure B2C, where security is scary. So we're going to let everyone else do it. Now I am aware that Azure B2C is quite limited compared to Auth 0. If you want to do it all yourself, you use Identity Server, ASOS, or OpenIDICT. We're not going to pick winners here. We're not limiting you for what you want to do. My end goal, to be perfectly honest, is we will eventually have a button when you have ASP.NET Identity that goes, okay, I really don't want to deal with this anymore. Why can't I just shove it into Azure B2C and let them take care of it? So what you will probably see in ASP.NET 2.2 is we will move from having an HTML-based login form to ASP.NET Identity exposing itself as an OIDC service. So then you just need to comment out one line and add a different line for Azure B2C or for Identity Server or for Auth 0 or for something else. That was going to come in 2.1. We didn't like how it turned out, so it's getting pushed back to 2.2. So the reason we want to do that is just we want everything to be standards based. We don't want you to have to deal with awful HTML forms anymore. And it's going to decouple the app from authentication code. So if you decide you want to swap things in, it's easier. It'll also support mobile and native applications. So if you want to have your website up there and have people log in through Auth on their phone, it'll be there. And it'll allow you to swap things out incredibly easily. So authorization.
Wait, so quick question on that. Did you mean that an OIDC server is coming that works as an aggregator?
Yes.
Okay, great.
Not as an aggregator. We will not aggregate. It will only talk to an ASP.NET Identity DB.
Okay.
You want an aggregator, you go for Identity Server.
Okay.
So how many of you in old versions of ASP.NET had to write your own authorize attribute? Sorry. That was a horrible, horrible process. And more often than not, I saw really, really bad examples of how it was done. Lots of code duplication, lots of really weird ways to bypass it. And we wanted to remove that requirement from ASP.NET Core. So we threw everything away and started again because this was my one chance to do it and upset the world. And upset the world we did, and some people are still upset that they can't do everything that you could do in a custom authorized attribute, and there are more things coming, and these things take time, but there'll be more stuff coming in 2.1 and 2.2. So we removed the idea of hard-coded rules and attributes where you could specify roles, or you could specify a username because someone thought that was a good idea. And we moved everything so you can use policies. And policies are just stuff that you express in code. And then you have policies, you have requirements, and you have requirement handlers. A policy is made up of one or more requirements, and a requirement can have one or more requirement handlers. We've also added resource-based authorization, so if you were trying to build a better SharePoint, which is a good idea, or perhaps not hard, you can base your authorization not only on the current identity, but on the resource that someone is trying to access. So if you imagine someone was trying to access a document on a website, you could take the current identity, you could take the document, and then in code you basically say, is the current user the owner of this document? Are they the original author? Yes, let them edit. But policies, because they can have multiple requirements, you can also have a requirement that says, is the user an administrator? Yes, let them edit. So you can clump all these things together. It will become more clear with demos, I promise. And we have custom policy providers. So if you hate what we've done, you can just throw it all out and wire up your own. So Tony Baer and Brooke Allen, who are the guys behind Identity Server, have a new commercial product called Policy Server, where they've taken our pieces, they've moved it out to a separate service, a separate website that you can run where you can define all your policies in this nice UI. And then they have replaced our authorization pieces with a call out to their service, which gives you an idea of how flexible it is. There is an entire workshop for this on my GitHub page that will walk you through it. If you have not gone through writing policies, I strongly recommend it. It will make sense. So we start off requirements. Requirements really don't have to do anything other than implement authorization requirement. There is no code. It is a marker interface. You can parameterize this how you want. If you want to add properties, feel free, and you'll be able to access them during your authorization pieces. And for each requirement, you implement at least one handler. And inside the handler, you must implement handle requirement async. And that will give you a context, and the type of the context will vary according to the framework you're using. If you're in an MVC, you'll get an MVC-specific context. You can access things like the routes. If you're in Signal R, you get a Signal R-related context. You can access things like the hubs, or whatever they call their magical orchestrators. And you get the requirement coming through. And so you just take the user and you go off to your database if you need to, whatever you need to do, and you try and figure out whether the current user can fulfill the requirement. And if it can, you can call context.succeed. If it can't, you leave it alone. You call task.completed, or if you're in the old stuff, you call task from result 0. And then I build my policies up with one